Hey everyone, and welcome back to this class, the NumPy stack in Python. In this lecture, we are going to look at another popular visualization called the histogram. The histogram is essentially just a discretized probability distribution of the data, or in other words, the frequency counts in each bucket of values. I'm assuming here that you still have the data from the previous lecture loaded up. So let's plot a histogram of the x data points. So that's plt hist x and plt.show. So this is a histogram of the x data points. And this is how many points in x fall into each bucket. Now, I claimed earlier that the random function gives us data that is uniformly distributed. So you might be wondering if we can visually demonstrate that this is the case. So let's try that. So r is equal to np.random.random, 10,000 data points. Let's do a histogram of this. Okay, so this looks pretty uniform. Another argument you can pass into hist is to control the number of buckets. So by default there are 10, but let's say we want 20. So we can do plt.hist r and bins equals 20. Let's show that. So now there are 20 bins. So it still looks pretty uniform, but less uniform than before. Remember that this is random, so you're not going to have exactly even splits in each bucket until you gather many more samples. Let's do one last example with the histogram. One assumption that we make when we're doing linear regression is that the error is normally distributed. So if we take all the y data points and subtract it from its corresponding place in the fitted line, then that data should be normally distributed. And we can check that it is normally distributed by doing a scatter plot. So we have all the tools we need to do this, so let's give it a try. So y actual is equal to 2 times x plus 1, and the residuals are equal to y minus y actual. So let's do a histogram of those. Okay, so it's more or less a bell shape. We only have 100 data points, so it's not going to be very accurate.